Let's suppose that you've taught a friend how to make a sandwich, and you now want to teach him or her how to make a sandwich tower. When describing the process for making this tower, would you detail the steps for making a sandwich? Probably not. You would most likely say something like, make 20 sandwiches and then put one on top of the other. And even if you hadn't taught your friend how to make a sandwich beforehand, you would most probably describe the process for making the tower in the same way, that is, by mentioning a sandwich making step. And then you would also detail the process for making a sandwich. In computer science terms, we have defined a procedure for making a sandwich, which we can refer to or call within the body of a different script. A procedure is a separate program, a sequence of instructions that describe how to carry out a particular task. This program can be used in other programs. In other words, it can be called whenever that task needs to be performed. Using procedures is very common in programming, as it allows us to define the steps of a particular task only once instead of every time that we need to carry it out. This way, we can reuse it again and again and be much more efficient, achieving the same results with less effort. In the case of the sandwich making procedure, for example, we can use it not only when describing how to make a sandwich tower, but also when explaining how to make breakfast or how to make a star-shaped sandwich. Defining procedures has another advantage too. They're more flexible and thus easier to modify. If at some point, for instance, we decide that we no longer want cheese in our sandwiches and instead we want a tomato slice, all we need to do is modify our sandwich making procedure. The rest of the programs that refer to making a sandwich can simply stay as they are. Scratch 2.0 allows us to define procedures by creating new blocks that are formed by sequences of instructions that we choose. When we want to call a procedure, all we need to do is use the corresponding new block. We'll now create a game in which we have a cat, a mouse, and a piece of cheese. The mouse is moving towards the cheese in order to eat it, and the purpose of the game is to make the cat jump by pressing the spacebar so as to catch the mouse. If the cat touches the mouse will return to the starting point. On the other hand, if the mouse reaches the cheese, it will eat it. How do we build this game? First, let's design an interface. This is what we want the game to look like. We have the cat, a mouse, and the cheese, for which we'll need different versions for when it is being eaten. Now, let's design our code. There are 3 main parts, one for each character in our game. These can be further decomposed like this. Let's create a new project in Scratch for this game. We'll first take care of the interface of our game.
We'll add 2 more sprites, a mouse, which we can find in the sprite library, and a piece of cheese, which we'll draw ourselves. We'll draw several costumes for the cheese in order to show how it's getting eaten. Each costume will have a representative name: entire, bitten, almost gone, and gone. We'll make sure that the costumes are put in this order. We'll also name each sprite appropriately.
Our game interface is ready. Now, let's program our characters to tell them what to do.
We'll start with the cat. At the beginning of the game, we want it to be placed around here on the screen. So we'll introduce a when green flag clicks block, followed by a go to block, and set the coordinates to be -18, -30.
We're done with the cat's initialization. Now let's look at its jumping behavior. In this case, we want to specify that the cat jumps every time the spacebar is pressed. It would be very useful to have a procedure for jumping. But what does jumping mean? We can define jumping as a movement of, say, 100 steps upwards and 100 steps downwards with a short waiting time in between. After defining this procedure for jumping, we can call it every time we press the spacebar. Let's implement this.
We'll go to More Blocks and make a new block, which we'll call Jump. We'll define this procedure just like we explained earlier. We'll also set the cat's rotation style. Good. We now want to make the cat jump every time the spacebar is pressed. Let's try it out to see if it works. Brilliant!
We've coded the cat's behavior, now let's program the mouse's behavior. At the game initialization, we place it at the top left corner, looking towards the right.
So we'll introduce a block for pressing the green flag, followed by a Go To block, and a block for pointing to the right.
For the mouse's movement towards the cheese, we identified this algorithm, which we'll enrich to include what happens when the mouse is caught by the cat. Let's code this.
We'll use a repeat until block, setting its condition to touching cheese. In order to make the mouse movement more realistic, we'll introduce small turns. We'll also use an if-then block to implement the selection for touching the cat.
It's time to implement the behavior for the cheese. When the game begins, the cheese should be located at the top right, and it should have its entire costume. Let's build this.
We'll include the green flag, followed by a Go To block, and then we'll introduce a switch costume block and set it to entire.
We also want to include the cheese's behavior when it is eaten by the mouse. This involves waiting until the mouse is touching it and then changing costumes to simulate that it's getting eaten.
So we'll introduce a wait until block, with a condition touching mouse. To simulate that the mouse is getting eaten, we'll successively switch to the next costume, waiting first for a short time. Since we have 3 additional costumes for when the cheese is getting eaten, we'll have these steps repeat 3 times. We're done with the implementation. Now let's try it out.
Excellent! We've developed a very nice game in which we've defined and used the procedure for jumping.
Can we use this new block that we've defined in other programs?
Of course! This is one of the main advantages of defining procedures. You can reuse them in different programs. If you're using the online editor of Scratch and you're logged in, you can save your blocks in the backpack and carry them along with anything else you might want to use in a different program, such as sprites, costumes or code.
Sounds good. And how does it work?
I can show you. Here, we've opened the same project by using the online editor logged in. If you click on the backpack icon on the bottom right, you'll see the backpack area, in which we can drag and drop the definition of any procedure, such as jump. Now, if we open a different project or create a new one, we'll see that this script is still in the backpack area. We can drag and drop it into the script area. Once we do that, we can go to the More Blocks palette and find the jump block, which we can use just like in the previous project.